this video, we'll be taking a look at a very important electronic device on your vehicle, a MAF sensor, also known as a mass airflow sensor. This sensor is used by the ECU, or engine control unit, to determine how much air is entering the engine. Once the computer knows how much air is entering, it will automatically adjust how much fuel is injected into the cylinders for the correct fuel-air mixture. Now, if you were to take the power wire going to one of the fuel injectors and connect up a scope, you would see pulses being delivered to the fuel injectors. What the computer is doing is adjusting the on time for the fuel injector. So if you look at this right here, pulse width modulation, 0 volts along the bottom, 12 volts along the top. You can see that over here it is off, and then it gets power. It's on for this duration, then it goes off again, then it goes on again, and it's roughly 50% duty cycle because the on time is very close to the off time shown in this image. If the computer thinks that the engine is running lean, what it's going to do in order to get that fuel-air mixture just right, it's going to take the pulse and it's going to make that on time, which is right over here, longer. By doing that, more fuel is going to spray into the cylinders, and it should make the fuel-air ratio correct. And it would look something like you see right over here. So let me just draw it quickly. All right, so it'll be there. And it'll go on longer. Then it'll go off. Then it'll go on longer. Off, something like that. If the opposite happens, where the engine is running too rich, what the computer will do is make sure that those fuel injectors are supplying less fuel into the cylinders. So instead of having it like you see here, it might be something like this. This is going to be off most of the time, and only at these points right here is when you're going to have the fuel injectors spraying fuel into the cylinder. And it's very simple. That's exactly how the computer controls the fuel injectors. Since air's density changes with temperature, cold more dense, warm less dense, the unit works in conjunction with an intake air temperature sensor. Intake air temperature sensors are either incorporated into the unit. This one here, as you can see, only has 3 pins. 3-pin and 4-pin models usually do not have the intake air temperature sensor inside. They will be mounted on the intake plenum. And the reason for these intake air temperature sensors is to ensure a high accuracy measurement with this unit. Once the computer adjusts the fuel rate, it will look at the upstream oxygen sensors, the 2 that are closest to the engine, to see if everything is balanced. If it isn't, then the computer can try and adjust the amount of fuel until the oxygen sensor levels become normalized. If you have a problem with the engine where both banks are running too rich or too lean, and you get PO 172, 175, 171, or 174 codes from your ECU, then you have a very high possibility that your MAF is either faulty or dirty. Now, you can clean these using a mass airflow cleaner made by CRC, and what it does, in a minute I'll show you what the sensor looks like, it will remove any dust or other contaminants which may be on top of the sensor, not allowing this unit here to give a good reading of the airflow into the engine. It's also very important to take a look at this unit right here. It is directional, how the air flows through it. Let me rotate it around. Hopefully you can see there's an arrow right here pointing to the right. This side is wide open. It directs the airflow a little bit, but you can see on this side here, it has a honeycomb. The purpose of the honeycomb is when the air gets drawn into the engine, it goes through the air filter first, through the hoses, into this side of the unit before exiting and going into the throttle body. You want to make sure that the airflow isn't turbulent. You want to have it as smooth flowing as possible when the readings are taken with this unit, and that's the purpose of the honeycomb. If only one bank is running too lean or too rich on your engine, then you may have a faulty oxygen sensor or fuel injector. Fuel injectors could leak or be stuck in the open position, resulting in the engine running rich, or they could be stuck closed, resulting in one side of the engine running too lean. This is one part of your vehicle that you definitely want to replace using a genuine OEM part. Genuine OEM parts are calibrated to match your engine. Aftermarket mass airflow sensors, like the one you see here, may not work well with your vehicle's computer and even cause problems. It's important to note that a faulty MAF can also cause transmission shifting problems, just like the throttle position sensor on your vehicle. The engine control unit, the ECU, works together with the TCU, also known as the transmission control unit. The type you see right here uses a hot wire sensor. There are other types available, such as a moving vane, and it's connected to a potentiometer, so as the airflow moves through it, it will move the potentiometer. The only problem with those is it does have moving parts and it's not as accurate. Now when I open this up and show you the inside, you're going to see that there's actually two wires. One heats up when 12 volt DC is applied to this unit, and the other one remains cold. The purpose of the cold one is a reference while the other one is heating up. When this heats up, it will draw around 65 to 80 milliamps. Once air flows through, it's going to cool that wire, and as it cools it, the current is going to go higher. When the current goes higher, over here, this first pin on the left is the power 12 volts DC, far right is the ground, and the middle one is a sensor output going to the computer. It could have an analog output up to 5 volts, or in this case, this one puts out a particular frequency as the airflow changes. The best way to test these, what you would do is take that center pin while it's connected to the engine, connect it up to a portable oscilloscope, and then you could read the frequency as well as look at the voltage peaks and compare the readings that you get at specific RPMs to what the manufacturer shows. Now the hot wire that's used inside this unit is made out of platinum. Because it's so important to have this extremely clean for an accurate read on the airflow into the engine, some of these mass airflow sensors have a burn-off circuit, and what that does, when you turn off the key to the engine, current will be supplied to the sensor, making it very hot to burn off any contamination which is on that sensing element, so the next time you start the engine up, you'll have a very good read of the airflow. Okay, let's take a closer look. I'm going to pop off each side. Let me actually take off the honeycomb first. Alright, take a screwdriver, reach right in here, carefully pop out the honeycomb. See how thick. And with that off, you can see the hot wire sensors. There's one there, one there. Let me zoom in. The wire wraps around that centerpiece, and the bottom has the same thing where the wire wraps around. In the past, I've seen one of these wires that were completely melted away, and that explained why the engine was stalling all the time. So you could do a visual inspection first, and then after you do the visual, then you can connect up your digital multimeter to make sure that the mass airflow sensor is getting 12 volts DC, that it's properly grounded, and then you could test that sensor output using a portable scope like I mentioned earlier to check the voltage peaks as well as the frequency using different engine RPMs. Take the engine RPMs, compare it to manufacturer specs for your vehicle to see if they match up. If they don't match up, then you're definitely going to want to swap out the mass airflow sensor. Now if you're going to clean this with the CRC cleaner, I like to pop off one side where the honeycomb is because it's so easy to do. On the very bottom down there, you're going to fold a towel, and then you're going to spray the cleaner all over the two sensors. You may only have one. Spray a bunch of times, spray it, wait, spray it, just keep doing it, and then when you're done, just allow it to dry thoroughly for about 15 minutes before putting the honeycomb back on and reinstalling into your vehicle. Now before I pop the cover off here to see what's behind it, I just want to show you in here that these are very fragile, but not to the point where you couldn't touch them. They are very stiff. My finger's touching it now. And remember, you don't want to do this. I'm throwing this one in the trash because it's been installed for a long time and I was having problems with it. My finger's actually putting an oily film, which would cause the reading to screw up, so you definitely have to clean this. But it's not that fragile that it would break by touching it. It's very tight, the wire. Right here's a little demo. Positive from the battery, negative, just like the engine's running with the alternator, 14 volts being supplied, 60 milliamps of current, and the one that's heating is the one towards the back. And it's going to be very hard to give you an accurate reading using a thermocouple because it is so tiny. What I'm going to do though is just touch this right on each sensor, and we're going to look at my digital multimeter to see the temperature. So let's put this over here. You can see the 87 degrees. Let me reach in. So the one here, nothing going on. And the one back here, you get right on it. It's very tiny, and the thermocouple's very thick compared to it. So I'm not going to get a good read on it, but this should get very hot. Right? Barely touching it too, barely touching it. But you got the idea. That one is heating in the back, and this one is not. Yep, that's the one that's off. From what I read about these, it should get to around 375 to 400 degrees Fahrenheit. Because this wire is so thin, only so much current can flow through it, because the resistance goes very high after it heats up. When you blow through here, the resistance will drop, causing more current to flow. What I'm going to do is blow through here, and you'll see the current level go from 60 milliamps much higher. Let me bring this a little closer. Right over here, I'm going to blow through it, right at this angle, blow through it, and you'll watch the current right there. As you just saw, the current went up to 80 milliamps. That was with me only blowing through it. So with an engine at a very high RPM, with a lot of air being drawn in, that value could be well over 125, 150 milliamps. Okay, now let's pop this open, see what kind of circuitry is under here. Okay, the cover was on there pretty good. It was thermally sealed. I was able to pop it off using pliers by squeezing. You could see the circuit board in here. Now the circuit board, with this integrated circuit, along with these potentiometers that we use to calibrate the unit, that's what produces that output frequency, which goes to the computer. Depending on the airflow going through the mass airflow sensor, the output frequency will vary. You can see numerous resistors as well as other components. This was painted over, I guess because they don't want anybody touching the calibration. And in reality, if you knew exactly what the value should be with this unit compared to what the manufacturer's specifications were, you could probably take off this paint very gently and fine-tune it to match very closely to an OEM unit. I hope you enjoyed this video. If you did, be sure to rate it a thumbs up, subscribe, and post links to this video on other websites and blogs. Also be sure to check out my video playlists as well. Thank you very much for watching.